As we look at this issue, it's part of a sort of larger set of investigations that we're undertaking to think about the context in which food and nutrition are delivered to households. One thing that one notices right away in Nepal is that isolation is quite important. And I have two maps here, one on the left that shows the probability of stunting nationwide, and the map on the right shows the VDCs in the country that at the time of the data did not have all-weather roads. And there's quite a bit of overlap between the VDCs without access to all-weather roads and the VDCs where we see very high rates of malnutrition. And that's probably not surprising. But one question would be, why is that the case? And so part of our motivation here is to think about the following question. So think of the following thought experiment. What would happen if we took a child from an area of the country with poor access to roads and holding sort of all of the characteristics of that child constant, move that child to an area of the country in which there was better access to roads? What would be the impact? And so that's essentially what we're trying to do in this study. There are numerous connections between infrastructure and nutrition. Most of the ones that we're interested in are through the agricultural pathway, but there are also pathways that have been documented through access to health facilities. And in fact, one thing that seems to be quite important is the wealth effect of access to roads, perhaps as they're mitigated through labor markets or through asset markets or access to output markets for farmers and the like. So what we're trying to do here is measure the causal effect of roads on child nutrition. We're looking at height for age and weight for height z-scores. And we're using a dose-response function. So you can think about the density of roads as some kind of treatment, and we're taking advantage of the fact that we observe the construction of roads over time, so we know how the dosage of infrastructure is changing over time, and we're using DHS survey data from 2006 and 2011 to look at how district-level performance changed over that time period. And then a second thing that we're quite interested in is whether there are externalities or spillover effects from bridges and roads. So for example, if one area receives a road or a bridge, does that have a beneficial effect on people in adjoining areas? And let me just say right up front what some of our main findings are. So the things to be looking for are the following. If you think about increasing the density of roads, we find a significant effect on height for age and weight for height z-scores. The effect is a little bit larger for height for age than weight for height. And if you think about moving a child from an area with no roads to an area with the highest density of roads observed in the data set, we get an improvement of about 1 standard deviation in height for age z, and about half a standard deviation improvement in weight for height z. So those are quite large, and that's after we control for a lot of the things that you would expect to see in this kind of study, so education levels, child age, birth month, birth year, and those kinds of effects. We do find differences across different age groups, and some evidence of positive spillovers to adjacent districts. And this gives us a couple of policy implications. First, all of us who are interested in nutrition should also support our fellow researchers and policymakers in the Department of Roads and be champions for roads, because over time, upgrading roads and bridges will lead to improved child nutrition outcomes.
We conducted analysis at the district level because the benefit of road is likely to be broad in geographic scale. Therefore, we organize our data at the district level. Our child nutrition data, that's the G-score, comes from the Nepal Demographic and Health Survey. Road data comes from Department of Roads. And since we know that child nutrition influenced by various factors other than roads, like agriculture, literacy, health infrastructure. We procure data from various sources like Central Bureau of Statistics, Ministry of Agriculture Development, Ministry of Population Health, and Department of Hydrology. The main aim of our study is to casually estimate the impact of roads on child nutrition outcomes. But we know that the roads are not randomly placed in a district because the politically favored districts or economically well-off districts receive higher attention and public funds than those districts the different projects focus on the underdeveloped districts. So in order to isolate the impact of roads, we implemented instrumental variable and generalized propensity score approach to remove the bias associated with purposeful placement of roads in the Nepal. And we know that if one district have a very rich infrastructure, that this is not likely to influence the child nutrition outcomes in not only their districts, but it also influences child nutrition outcomes in neighboring districts. So that's called the spatial externality effect. So our study also estimated the spatial externality effects. And we conducted separate analysis for children below 5, between age 3 and 5, and below 3, because child growth can be differentially sensitive to overall condition at different ages. So we are trying to see whether there's any such a difference or not. It's very tricky to estimate the impact of roads because some districts have more blacktop roads, some only have earthen road, and to get a meaningful indicator of roads, we computed weighted road index that account for length and quality of the roads. We created an index in such a way that seal roads or blacktop roads is 5 times effective as gravel roads and 20 times effective as earthen road. And in our main paper, we changes these assumptions and did the sensitive analysis, and our results holds true for changing those assumptions. And as we know that height for age is a measure of long-term child nutrition outcomes. And therefore, what we did is, we consider road index in 2006 as a treatment for outcome height for age in 2011. And in case of, and we know that weight for height, G-score is a short-term measure of child nutrition outcomes. Therefore, what we did is, we consider treatment as a change in road density index between 11 and 6 as a treatment for the outcome weight for height G-score in 2011. And it shows that there's a high positive correlation between height for age 2011 and road density index in 2006. And there's a high positive correlation between weight for height G-score in 2011 and a change in road density index between 2011 and 6. Okay, so this is the results from the dose response function. That's a generalized propensity score approach. As you see here, this is a red dotted line, and this is the treatment benchmark. This is the lowest treatment level observed in the data sets, and this is the solid line is the dose response functions, and this horizontal line indicates the treatment threshold level. On an average, children that are beyond this threshold level are free from stunting in the districts. And you can see that this has a positive slope, and it exceeds the treatment benchmark level in the entire range of this treatment level. This shows that roads has a positive impact on height for age child nutrition outcomes. So this is the dose response function for the weight for height G-score for children less than 5 years of age. So as you can see here that the dose response function is, the slope is positive and upward. So this suggests that there is a positive impact of treatment on short-term child nutrition outcomes. Next, please. So, in summary of the results, our treatment effects differ across age cohorts. In case of height for age, marginal effects of roads are highest for children between 3 and 5 years of age, and in case of weight for height score, marginal effects of roads are highest for children below 3 years of age. We find that local changes in road networks are clearly associated with improvement in height for age score and weight for height score, and we find that roads have positive spatial spillovers on height for age, especially for children below age 3. And in conclusion, since we find broad and beneficial health and nutrition pairs from the transportation development, we would like to suggest government and development agencies to focus on to allocate the budget on constructing and operating of roads that will eventually translate over time into better child nutrition outcomes. And thank you for listening.